All right, what's up, everybody? So, this second video is an introduction to this idea of data tables. It's expanding on our module number 2, organizing data. So, we're going to start with this idea of a frequency table. I've already actually introduced you to frequency tables. We've been talking about them in the context of frequency tables slash frequency distributions. But I wanted to show you an example of a frequency table and then juxtapose that against another type of um, representation of data, a slightly different form, but a form that is particularly important because not all tables are necessarily constructed the same. So, with frequency tables, the left column represents categories, the right column is frequency. We discussed this in the last video when talking about this question of what is the longest amount of time in days that you avoided social media. We surveyed 30 people. This was their data. And remember, when it comes to a frequency table, we're talking about taking this question, or rather this data that we've collected, and organizing it such that the left column has our categories, the right column has our frequencies. But it is possible to collect a different kind of data that we may represent differently. For example, let's say that we were surveying people about their age, but we only had a small number of participants. Maybe we're conducting an experiment where we have um, maybe only 5 or 6 people in one particular control group. We have 5 or 6 people in our experiment group. There's a different way that we may need to consider representing that data. So we have what's called a participant data table. In a participant data table, the left column represents the individual participants, while the right column represents individual scores or data. So we have each person identified by a separate letter and their particular age associated with that person in the right column. Okay, so again, it's still within the realm of this idea of representing data, but you want to make sure that when you're reviewing any kind of frequency, any kind of data tables, really, you want to take the time to really get a good grasp of what kind of data you're reading through. This can in part be helped by a research results section that you might be reading alongside the research of the data that you're reviewing. But as training you to be a social scientist, you want to get in the habit of being able to look at a table of information and figure out pretty quickly, what kind of data you're looking at, and how it's been collected and how it's being displayed to you. Okay, so applying statistical notation to a frequency table. In module 1, we learned at the very last video covered statistical notation, and this is notation that are going to be important in our class, particularly when we are doing calculations by hand. As a reminder, when I say hand calculations by hand, I'm referring to quite literally pencil and paper, doing some math like that. On the other hand, we're also going to be using SPSS, but both of these components are important. So, as a matter of reinforcing what the notation means and how it is that it's applied in a real world scenario, so to speak, I'm going to provide a couple different questions, I suppose, about a data table that we can then answer. So, for this table that I'm about to present to you, we're being asked the three questions. What is the sum of x? Remember that when you see that E looking symbol, that represents sigma, which means the sum of. So this first question here is what is the sum of x, which means the sum of all scores in our data set. What is the sum of x squared? This one, compared with the third one, can be a little bit tricky, but what the second one means, the sum of x squared that doesn't have any parentheses, this means that each score is going to be squared first, and then you are going to add up all the scores together. And then finally, what is the sum of x in parentheses squared? This means you're going to add up all the scores first, take that total, and square it. In case you might need a little bit of a refresher about what squaring means, squaring means that you are multiplying a value by itself. So when we are being asked the sum of x squared, let's say, for example, x in one instance is 8, then we are multiplying 8 by itself, right? 8 times 8, which equals 64. On the other hand, this sum of x squared, remember, you're adding everything up and then you're multiplying that number times itself. But let's apply this. So we're going to bring back this table, this frequency table on social media avoidance. Here's where it might seem a little bit tricky. You're thinking to yourself, okay, we've got this first question. What is the sum of x? Looking at this table, this is where I want to remind you, just like we saw in the first video for this module, this left column is representing the category. The right column is representing the frequency. Remember that in this case, the frequency column represents all 30 people who have participated in our survey. So we have to remember that there are 3 separate people who selected 8, right? 8 days that they've avoided social media. So we have to then add 8 together 3 times. Okay, if we're accounting for each person that has participated, we have, of the 3 people who said 8, we have person number 1 said 8, plus person number 2 that said 8, plus person number 3 that said 8. And then we go to the next number. We have 3 people who responded with 7. We would add, 8 plus 8 plus 8, plus 7 plus 7 plus 7, plus 6 2 times, plus 6 plus 6, then plus 5 2 times, so on and so forth. So to calculate the sum of x for this table of data, we are going to add 8 together 3 times, 7 together 3 times, 6 2 times, 5 2 times, 4 3 times, 3 4 times, 2 4 times, 1 6 times, and 0 3 times. Don't leave these people out. I understand that they're zeros, and you might think to yourself, well, when I'm adding 0 to a total, then it doesn't add anything. While that is technically true, I would encourage you to get in the habit of including those 3 people as a reminder to you that when you are working with this data set, you are working with 30 people. If you leave out those last 3 people because you think to yourself, right, they're zeros, I'm not going to include them, you might accidentally trick yourself into thinking that you're only working with 27 people. So as a matter of habit, I encourage you to include those 3 zeros at the, as you are adding through this particular equation. I should have the numbers in front of me, and unfortunately I don't. So I'm going to bring up my calculator. I'm going to do this myself. Give you a little tip here. When we're working with a frequency table like this, notice how I mentioned, 8 plus 8 plus 8, 7 plus 7 plus 7, so on and so forth. One trick, one shortcut that you can take is to multiply your category by the number of times it's come up. If you multiply 8 times 3, you get 24. 24, represents the sum of x for this first category. So, I would encourage you even to make a separate column, rewrite this table, have your categories on the left, your frequencies on the right, make another column to the right where you're, doing the sum of x. So here we would have 24 plus 7 times 3, which is 21, plus 6 times 2, which is 12, plus 5 times 2, which is 10, plus 4 times 3, which is 12, plus 4 times 3, I'm sorry, 3 times 4, which is 12, plus 2 times 4, which is 8, plus 1 times 6, which is 6, plus 0 times 3, which is 0. I ended up with 105. So if you got 105, and I did my math correctly, now we're on the same page and we got 105, right? So your sum of x for this particular table should be 105, right? So that's the sum of x, adding up all the scores in your data set together to determine what is the total number of in this case days of social media avoidance.